This is test ID 39, component ID 00. It's the pre-catalyst or fuel control oxygen sensor B2S1. It's the heater time to activity test. There's a direct relationship to the heater performance and the time it takes for the oxygen sensor to become active. Component ID 00 indicates we have a maximum limit, and this is the right side sensor or a rear sensor in a transverse engine when dual O2 sensors are used for fuel control. The PCM monitors fuel control oxygen sensor voltage during warm-up to determine the time to activity. As we've said, this relates directly to the oxygen sensor heater. Special note, JTEC O2 sensors have 5 volts present when they're cold, but you cannot read this with some instruments, particularly generic scan tools and lab scopes. You may want to review the section on JTEC O2 sensor operation. Now the values you're going to see aren't converted into measurement values. Use the data as a relative indication of performance. We'll show you some typical data from a vehicle. This is something we captured a while back. Remember, it fails when we exceed the maximum. Now this doesn't relate to seconds directly, but it has some relation. The maximum limit is 4102 on this particular vehicle. We were 1656. Let's see what a pattern looks like on a lab scope. It's far easier for us to see on a lab scope than it is if we go back. Now we have 3 areas to look at here. Notice it gets down to 0.2 of a volt at the bottom, passes through 1/10 in the middle, and starts out at a 1.6 volts. So this is the type of stuff we're going to be looking at on the lab scope. We'll see this form live. So next we're going to go take a look at these lab scope patterns and see how to verify this mode 6 data. Now the red scale is on the right and the green scale is on the left. Notice the slope during the warm-up period. We're going to let it go live here in just a moment. This is fuel control. Starts off at 1.5 volts on the left, drops down to 1 volt on the right. Now JTEC has special warm-up procedures. Make sure you go look at that section because you need to understand how this works. We have changed these readings by attaching a lab scope, but you need to be aware of that. Notice in the center here, we drop below 1 volt and we start seeing some activity. That's the indication of fuel control. Now once we get into fuel control, we can change to 1 volt on these scales, and you can see we are in fact in fuel control. The warm-up is complete. This is where we should see fairly quickly after we start up. Now let's go back and look at this and talk about why we had to change scales. If we look just back at the plain scale, we're looking at a 100-second scale here. As you can see, once we start looking at it, it stays the same until we change scales. We can't tell much about it, but this is what fuel control is going to look like if you stay on the 5-volt scale. And you need to be on the 5-volt scale to start this process. So we're spending a little more time here than we normally would. But now let's go back and look at the whole thing so that you know what's going to happen. We're going to start off high. It's going to drop down in the middle. And this is all about the heater, remember? So if we're worried about warm-up, we need to start worrying about the heater. And to get to this point, the heater's going to have to operate properly. And as we said, once we're here, we're fully warmed up. Well, let's say it takes too long. Then we need to go examine the heater. We're going to look at the voltage and the current. And we're going to do a starting test. Did you see it? We turned the key on. Here, we stopped it so you could see it. At key on, we got battery voltage from the SD relay, and we had heater current. Now we're going to examine that current more, but you're going to have B+. You need a good schematic like this in order to diagnose it. If you don't have a schematic like this, get one because you can't diagnose any other way. Remember, this works because of the 5-volt pull-up on a cold sensor. So let's talk about this current flow. We're going to make some measurements of this current flow. Here is our measurement at startup. We had 1.89 amps at startup. This means we have full power and a good ground, and the resistance of the heater element is normal. That's what this tells us. Now, if we look a little further down toward the middle of this, we can see that it's sloping down. Notice the downward slope. Well, let's go put a measurement on that downslope and have a look at that. When we look at the downslope, we found after 25 seconds, we're down to 0.886 amps. This says we have normal warm-up. This is what we're trying to test. If this current flow is normal and the heater doesn't warm up properly, change the sensor, because we've got normal power, normal ground, normal heater resistance. We test both the current flow and the time to activity. And this is the ideal way to do this testing.